kids, we are here in lesson 15. We're going to jump right into the book. It's kind of got some long word problems. And I can hear thunder outside, and I think, oh dear, I hope I keep my power on and my internet going. So let's jump right in. Our strategy today is to use the RDW, which is read, draw, write. And essentially what you want to try to do is make a model if you can, set up a calculation, which you should do anyway in the beginning before you just jump in and start solving, and then think, is my answer reasonable? So these are some real world problems, so it always makes more sense if everything is like a real world problem. So let's get to it. The length of a flower bed is 4 times as long as its width. If the width is 3/8 of a meter, what is the area? So let's get started. It sounds like a tape diagram problem where if you said the width is 1 and the length was 4 times, you could read and then draw and then label what you do know. Okay, the length is 4 times as long as the width. So we know the width, and if we're going to find the area, write your formula. What we don't know is the length. So we're going to do 3/8 times 4 because I need to know what 4 of these are. We can simply cross cancel here and get 3/2. And since we're trying to have a fraction, I could change this to 1.5 if I wanted, but I can also just leave it at 3/2 times 3/8, which is really what I need to do to find the area over here. Since I cannot cross cancel, the area is 9/16, and check your unit, meters squared. How about that? Starting off nice and easy. Simple. Let's move on as we get to less simple here. Mrs. Johnson grows herbs in square plots. Thankfully, her basil plot measures 5/8 yard, notice the units, on each side. So this is 5/8 yard. It's a square, so this is 5/8 yard. Okay, find the total area. No problem. I know how to do this. Use my formula. 5/8 times 5/8. Look to cross cancel. Can't do it. And I have to measure my, write my units. And so the total area of the basil plot is 25/64 yards squared. Another easy problem. Now, here's where the fun begins. Mrs. Johnson puts a fence around the basil. If the fence is 2 feet from the edge of the garden on each side, notice the different unit. What is the perimeter, not asking for area anymore, of the fence in feet? Perimeter is the distance around. So first of all, I need to be using the unit for the total length that I want to label and I want to multiply. So this goes back to the tool belt where you take your 5/8 yard and go, how many feet is that? And you may have forgotten how to convert. So remember, it's just copy what that is times 1 of the old unit, 1 yard. The real magic takes place right here when you have the equivalent times the equivalent of the new. Now I need to know how many feet are in a yard, and that's going to be 3 feet. So 5/8 times 3 over 1, and we get 15/8, which you could use again like we did up at the top, or you can change it to a mixed number. Almost 2. And so that's going to be our feet. So if I want to label this section here, okay, and I know that this part here is 2 feet from the edge all the way around, That's 2 feet. If that's 2, again, this is 2, and this is 2. So what I really need is just that section. So it's going to be the 2 plus the 2 plus what we just found. So it's 2 here, it's 2 here, and then this section right here is 1 7/8. So the total amount, and this is a square, thankfully, 2, 4, 5 7/8. Okay, now we need to find the perimeter. So when you find perimeter, you can multiply by 4, or you can add all 4 of them. So let's do, my goodness, I can hear a lot of noise out there. Okay, you can also do times 4. 5, 10, 15, 20. 7, 14, 21, 28. Convert. Sorry, thinking. And change the 4/8 and label it with our units. And this is going to be the perimeter. Perimeter. Okay. It's not feet squared. It's not feet cubed. It's linear units. It's going around in one direction. You can think of it as going around and around and around. And you could also do 5 7/8 times 4 and then split it out and use the distributive property like in the previous lesson. Okay, that totally works. But we have lots more to do, so if you need more time, you'll have to go back and pause the video. Now, what is the total area in square feet that the fence encloses? Now we get to multiply. 5 7/8 times 5 7/8. And let's use the distributive property here because our numbers are a little bit bigger. 5 times 5. First times first, first times second. Put this in a whole number over 1. Second times first. Second times second. Multiply. Calculate. Look to cross cancel. You can't. Same thing. Kind of weird fraction here at the end. Trust the math. Some of them are weird. Okay. Make mixed numbers whenever you can. 8 goes into 35 4 whole times because that's 32. And with 3 left over. Twice. I don't know if you guys can hear the thunder. It's pretty cool. Rumbling. It's a rumbling. Okay. 29, 33. Put your eighths together for 6/8. And then we have our 49 64ths. So let's handle this right now. I need to have 64ths. So don't forget your 33. Let's just move it up here and make these eighths into 64ths. 8 is my scale factor. 8 times 8 is 64. So 6 times 8 is 48 and 49. And then you get to add those. And adding, not multiplying, 17, 97 64ths. Okay, and so 64 goes into that one time, so that's going to give you 34. And how many are left over? The difference between 33? Okay, and so that's your final area, 34 and 33 64ths feet squared. Yep, kind of weird, but that's the answer. So trust the math and keep at it. Be strong. You can do this. Okay, let's do another one. Janet bought 5 yards of fabric, 2 1/4 feet wide, to make curtains. She used 1/3 of the fabric to make a long set of curtains and the rest, the 2/3, to make 4 short sets. Find the area of the fabric she used for the long set, and then we're going to have to find the area of the fabric she used for each of the short sets. So let's find this 1/3. If you make a model and you think about these tape diagrams that we've been working with, okay, so we have fabric. It's 5 yards long and 2 1/4 feet wide. 2 1/4 feet. What? Notice. And 5 yards. Sorry, I'm not underlining. I'm just making this whole thing 5 yards. But I don't want to ever have amounts that don't match. So I'm going to convert right away. How can I divide yards into feet? Remember, equals how many feet you need to be able to convert. And then 1 yard is equal to 3 feet. And now we have this whole thing, which is 15 feet, and it makes more sense when it is broken into 3 pieces. So essentially what you can do right here is label this as 5 feet. Now I can find the area of 1 square, 2 squares, 3 squares, and I can find the area for short sets as well. Okay, so find the area she used for the long set, and the long set is for 1/3. So that's going to be 5 times 2 1/4. And if you want, I'm always like, I don't know, I don't want to always have to do it the new way because I just want to go 9/4, 9/4. But you can do that if you want. And then 5 times 1/4. But this is the distributive property, which they love it when you practice this skill. And it turns out pretty easy this way. Feet squared, 11 1/4 feet squared for the long set. And that's the answer for that one. Then we can go on and find the area. Now let's go back to the problem, because it says she used 1/3 of the fabric to make a long set of curtains and then the rest to make 4 short sets, which if you divide what's left into 4 short sets, boy, does this picture open up a whole lot of things you can do. Okay, what's the area of the fabric she used for each of the short sets? Well, what they want to know is, what is this right here? Well, you've got some options here on how to solve it. I've had students come up with the greatest stuff, and so I'm just going to kind of write it out 3 different ways, and you can decide which way you want to solve it. Some students said, well, we already figured out the area for this whole thing, so can't you just find half of 11 1/4? And I said, yes, you can. And then some of them said, well, if I know the length and the width, can't I use my formula? And I know that half of 5 is 2 1/2, so you could do 2 1/2 times 2 1/4 and do the length times the width that way. Okay, so that's the length times the width. Yes, you can. And then I've had other students that said, well, if you know that this is 10 and you know that this is 2 1/4, couldn't you do 10 feet times the 2 1/4 and then divide by 4? And I said, yes, you can. So you have a lot of things you can do here, and I don't really care which one you choose. Do what you like best. But let's take this one here since it's already kind of all set up, and we'll do the improper fraction way, the old way, which is always a favorite. And then it works out pretty easily to give us feet squared. 5 5/8 feet squared is the area for each of the short sets, or basically half of what that is. So lots of good stuff there, but there's more. But wait, there's more. There's another page. So we're making good time, but this one is pretty busy, so get ready to draw. Some wire is used to make 3 rectangles, A, B, and C. Rectangle B's dimensions are 3/5 centimeters larger than rectangle A's, and rectangle C's are another 3/5 centimeter larger than B. Rectangle A, finally, they give us the dimensions 2 by 3 1/5. So what's the total area of all 3? So we have to do calculating to get the length and the width before we can even find the area of anything. So let's draw. Oops, got a little horn there. Let's just call this A, make B a little bit bigger, and make C a little bit bigger than that. Okay, we do know that A is a 2 by 3 1/5. These are centimeters. Label it, it can help you. We also know that in order to find the area, we will have to do our formula, use our formula, length times width. So 3 1/5 times 2. I'm going to try to separate these. So we'll do 3 times 2 plus 1/5 times 2. 6 plus 2/5 equals 6 2/5 centimeters squared, and that's for A, so we'll leave that there. It's not the final answer, it's one part. Now, I don't even have my length and width of part B, so I need to go back and see what to add. I have to add 3/5 to both of these numbers. So I'm taking 3 1/5 plus 3/5, and I'm taking 2 plus 3/5. So that gives us 3 4/5 and 2 3/5. Okay, so now that's our, we're going to plug these in. Okay, now let's separate this out. Let's do it here. 3 times 2 plus 3 times 3/5 plus part 2, 4/5 times 2 plus 4/5 times 3/5. Okay. And then just to keep that separated, and I'll label on, oh, there go the lights. And there's still power. Whoops, there's still power, but we are still here. And I bumped something in the dark. Okay, that went super dark because it's really cloudy outside. So now we'll solve here, 6, and then 9/5. It's always fun to see what's going to happen in my classroom on my fun videos. And 12/25. Let's go up here. Okay, so making mixed numbers so that I can combine everything. 6 plus 1 4/5 plus 1 3/5 plus, leave that last one, 12/25. 6 7 8, and then 4 5 6 7/5. And leave this last one alone. I don't have to deal with it just yet. Okay, this one is 1 2/5, so that'll be 9 2/5 plus 12/25. Thankfully, this is a multiple. 25 is a multiple of 5. So I'm going to change this to 25. So leave the 9 alone. Times 5, so that would be 10, and then 12/25, leave it alone, and squeeze it in. Actually, I'm just going to put it below. So we have 9 and 22/25 for B. See what I mean by there's a lot of stuff here? Okay, now we still have to do C. So we're going to take our 3 4/5 plus 3/5 and take the 2 3/5 plus 3/5. We still need our length and width. So if this makes 7/5, that's really equal to 1 2/5 plus the 3. So it's 4 2/5 for the length. And then this one is 6/5, which is really 1 1/5 plus the 2. So this side is going to be 3 1/5. Okay, so we have 3 1/5 and 4 2/5. And that's going to be our new area equals length times width. So write that out. That's our length times width to get the area of C, and then we have to put all three of those together. And then again, first times first, 4 times 1/5. Move on, get the second part, 2/5 times 3. And 2/5 times 1/5. And if you want to do 22/5 times 16/5, you're welcome to. You just have to do 22 times 16, and that's fine. So we're just breaking this down. So we have 12, 4/5, 6/5, and then 2 20/5. Put these together for 10/5, which is really 2. So 12 plus 2 is 14, and 2 20/5. Nothing else to add. Centimeters squared for C. Now there's one more thing to do, and that is to put everything together. So the 6 2/5 plus 9 22 20/5, these are so enormous, and 14 and, can you guys even see that? 2 20/5. So fortunately, these are both 20/5. So we've got all the whole numbers. 14, then 23 plus 6 is 29. Okay, all the whole numbers. And then let's make these into 20/5 right away. So if that has to multiply by 5, then 5 times 2 is 10. And then we have our fractions, and they're all the same. 22, 32, 33, 34, which would become 1 and 9 20/5, which I will then combine with my 29 to get 30 and 9 20/5 centimeters squared. Hallelujah. Amen. We are done with that one. Okay, so lots and lots of stuff. I know it's like a monster problem, and we're still doing okay on time. And this last one is not too bad. It's a perimeter question. Oh, the lights. Hello. Good heavens. Like, I am still here. What do I have to do? Jump up and down. Okay, 40 centimeter. If a 40 centimeter coil of wire was used to form the rectangles, these fun guys, how much wire is left? Don't forget, it's about how much is left, not how much was used. So now that we already have the measurements, you're going to take and organize your data. Okay, and we've got 3 1/5 twice plus 2 and 2. Remember, perimeter is distance around. 3, 6, 7, 8, 9, 10. 10 and 2/5. I'm just adding centimeters, not squared, not cubed. That's linear units on a line. This next one is 3 4/5 twice, and 2 3/5 twice. 3, 6, 7, 8, 9, 10, but 4, 8, 9, 10, 11, 12, 13, 14/5. This has to change into 2 4/5, so that will become 12 4/5 centimeters. Remember, linear units. Rectangle C. We have our measurements. It's 4 2/5 twice, and then it's 3 1/5 twice. 4, 8, 9, 10, 11, 12, 13, 14, 2, 4, 5, 6. That's 1 1/5. So that's 15 1/5 centimeters. Now, before I can figure out how much is left, I need to know what the total is. And I don't want to have to do 3 subtraction problems. I'd rather do 1 addition and 1 subtraction. So take your 10 2/5 and your 12 4/5 and your 15 1/5. And thankfully they all have fifths. So whole numbers, 10 and 12 is 22, and then 32, and then 37. 4, 5, 6, 7/5. That is 1 2/5. So 37 plus 1 2/5. 38 2/5 centimeters for all around. That's not the answer to the question. The question is what is left. 40 minus 38 2/5. 40 minus 38 is 2, but you still have to take away the 2/5. So down from 2, you're into the ones, and it's 3/5 that makes up the difference of wire left. I hope you loved this fun video where the lights went out. Come back again real soon. Click subscribe. We'll see you on the next one. Bye now.